We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Namaskar, my dear friends. In our previous video, you will learn about the introduction of engineering curves and different types of the curves like ellipse, parabola and hyperbola. Now, in this lecture, we are going to learn about the different methods to draw ellipse. Now, methods for drawing ellipse. Arc of circle method, concentric circle method, loop method, oblong method, ellipse in parallelogram, Trammell method, parallel ellipse, and directrix focus method. But as per our syllabus is concerned, we have to learn this arc of circle method, concentric circle method, oblong method, ellipse in parallelogram, and directrix focus method. Okay, now let us see one by one arc of circles method. Now let us see how to draw ellipse by arc of circle method with one example. Okay, if major axis and minor axis are given, say for example major axis is 100 mm and minor axis is 70 mm. Draw ellipse by arc of circle method. So first of all, you have to draw a major axis AB of 100 mm length, and from the midpoint of this major axis, draw a line which is perpendicular to AB and of length 70 mm CD. So the CD is a minor axis. Okay. Now we have to mark the focus F1 and F2 on this line AB. So for that, first of all, as per the definition of ellipse, we have to take the radius is equal to AO and center is equal to C and draw arc on line AB. Okay, so this is our focus F1 and similarly center is equal to C and radius AO and draw arc on another side of the CD. You will get the another focus F2. Okay. Now mark the points 1, 2, 3, 4 at nearly equal distance from F1 to O. 1, 2, 3 and 4. Okay. Now we have to draw the arc. So for that, first of all, center F1 and radius equal to A1. A21 radius and center F1 and draw one arc. Okay. Similarly, draw arc on another side. Okay, on another side of the AB. Okay, same radius R is equal to A1. Now center F2 and radius equal to B1. B21 radius, center F2 and draw R. Okay, so the intersection point of these two are P1 and P1 dash. Okay, now similarly, the center is F1 and radius equal to A2. Okay, and draw arc. Radius is equal to A2, center F1 and draw arc both sides. Okay, here and here. Now center F2, radius B2 Okay. Radius is equal to B2, center F2, and draw arc and get the intersection point P2 and P2 dash. Similarly, center F1, radius A3 and draw arc. Now center F2, radius B3 and draw arc, and you will get the point P3 and P3 dash. Now radius A4, center F1, draw arc on both sides. Now center F2, radius B4 and draw arc, you will get the point P4 and P4 dash. Okay. Similarly, you will get the points on another side of minor axis CD, that is P1, P1 dash, P2, P2 dash, P3, P3 dash, P4 and P4 dash. Okay. Now join all these points by a smooth curve. This curve is known as an ellipse. Okay. Now, if you want to draw a tangent and normal at any point on this ellipse, then okay. So this is normal. How to draw normal? First of all, if you want to draw a tangent and normal at this point P2, then join this point with F1 and F2. Okay, join this point with F1 and F2, and now bisect this angle F1, P2, F2. Okay, so this bisector is a normal of this ellipse, and if you draw a line which is perpendicular to this normal, it is known as a tangent. Another method is concentric circle method. Okay, the concentric circle method means the center of both the circle is same, or we can say the center is concentric on one point. So that's why this method is known as a concentric circle method. Now let us understand how to draw the concentric circle method. Okay, so for that let us take one example. The major axis is 100 mm and minor axis is 70 mm, and draw ellipse by concentric circle method. So for that, first of all, we have to draw a major axis is equal to 100 mm and draw a circle whose diameter is 100 mm, or we can say the circle of diameter is equal to major axis. Okay. Now draw a minor axis CD of 70 mm length, and from the same center draw a circle of diameter 70 mm, or we can say the circle of diameter is equal to minor axis. Okay, so the center of both the circle is O, so we can say the center is concentrate on this point O. That's why this method is known as the concentric circle method. Now we have to divide this circle into the 12 equal division. Okay, and name one on outer circle and one dash on inner circle. Okay, and this point is P1. Initial point of this ellipse is P1. Okay, now here you can see this point is 2. So draw a line vertical from this point 2. Okay, vertical upward line from point 2. Similarly, from the point 2, from the inner circle, draw horizontal line, and the intersection point of this vertical and horizontal line is P2. Similarly, draw a vertical upward line from point 3 and horizontal line from point 3 of inner circle, and intersection point is P3. Here, similarly, you can find the point P5, P6, P7, P8, P9, P10, P11 and P12. Okay, so you have to remember that you have to draw vertical lines from outer circle's point and horizontal lines from inner circle point. Okay, and the intersection points of these horizontal and vertical lines are the points of ellipse. Now, join all these points P1, P2, P3 up to P12 by a smooth curve. Okay, so this curve is known as a ellipse. Okay, and this AB is a major axis and CD is a minor axis of this ellipse. Now, if you want to find out the focus, okay, then AO as a radius, the C as a center, and draw R. So this point is F1, and similarly you can find the another focus F2 on this major axis. So as per the definition, this CF1 is equal to CF2 is equal to 1 half AB. Okay. Now, if you want to find out draw the tangent and normal at any point on this ellipse. Suppose you want to draw a normal and tangent at this point N. Then, first of all, join this point N with F1. So, draw line N F1 and join this point N with F2 and F2. Okay. Now, bisect this angle F1 and F2. So, this bisector is a normal of the ellipse and a perpendicular line which is normal with the normal is known as a tangent. Okay. This is the tangent. Now, next method is the oblong method. Draw ellipse by oblong method. Take major axis 100 mm and minor axis 70 mm long. Oblong method means you have to construct one rectangle and you have to draw ellipse in a rectangle. So these are the different steps to draw the ellipse by oblong method. Here major axis and minor axis are given. So first of all, draw a line AB is equal to 100 mm and line CD is equal to 70 mm and complete one rectangle of 100 by 70 mm. Okay, now we have completed this rectangle. So this length of this rectangle is 100 mm and height is 70 mm. Now from A to upward, mark points at nearly equal distance 1, 2, 3. Okay, here we mark the point 1, 2, 3. Name 1, 2, and 3. 4. Okay. Now similarly, we have to mark point here on this line AB. Okay, and name it 1, 2, 3, 4. Okay. Now you have to remember that the points are from A on this vertical line as well as horizontal line. Okay. Now join 1D, 2D, 3D and 4D is already joined. Okay. Now join C1 and extend this line up to the 1D. Similarly, join C2 and extend up to the 2D. Join C3 and extend it up to the 3D. Now this intersection point of line 1C and 1D is our point of ellipse. Okay. P1, P2, P3 and you can say it is P4. Now similarly, you can repeat this process on this side also. Okay, so join all this curve by a smooth curve. Similarly, repeat process on this side. Take the point here 1, 2, 3 and 4, and on horizontal line also point 1, 2, 3 and 4. Okay, now join D1, D2, D3 and D4. Similarly, here join C1 and extend it up to the D1, C2 extend it up to the D2, C3 and join all this point by a smooth curve. Okay. Similarly, repeat this process below AB line, so you will get the complete ellipse. So this method is known as the oblong method, or you can say rectangle method. Okay. Then next is the ellipse in parallelogram. Draw ellipse by parallelogram method. Draw a parallelogram of 100 mm and 70 mm long, sides with included angle of 75 degree. Inscribe ellipse in it. It is same as that oblong method, but here instead of rectangle, we have to draw the parallelogram, which included angle 75 degree. Okay, so steps are similar to the previous case. Okay, rectangle method. Now here we have to draw the parallelogram, and this included angle. This angle is a 75 degree. Okay, and draw a line AB of 100 mm and line CD of 70 mm. Now mark the point here 1, 2, 3 and 4. 1, 2, 3, 4. Similarly on this line AB 1, 2, 3 and 4. Now join 1D, 2D, 3D and 4D. Similarly, join C1 and extend it up to the 1D. Join C2, extend it up to the 2D. Join C3 and extend it up to the 3D. So this point is P1, P2, P3, P4, P5. Similarly, you will get point on this side also. Mark the point 1, 2, 3 and 4. Similarly, mark here in horizontal line 1, 2, 3 and 4. Now join 1D, 2D, 3D, 4D and C1 up to the D1, C2 up to the D2, C3 up to the D3. Okay, and you will find these different points. Now join all these points by smooth curve. Okay, and repeat this process below AB line. So you will get ellipse as a curve, and it is known as the ellipse in parallelogram. Now next method is a directrix focus method. Point F is 50 mm from a line AB. A point F is moving in a plane such that the ratio of its distance from F and line AB remains constant and equal to 2/3. Draw locus of point P. That means here this ratio is 2/3. That means eccentricity of this ellipse is 2/3. That means it is less than 1. So if the eccentricity is less than 1, then our curve is an ellipse. Okay, now how to draw ellipse by this directrix focus method? Let us see. First of all, to draw this directrix AB. It is directrix, and mark one point R1 on this directrix. Okay, and draw the axis. Okay. Now, distance between the focus and directrix is 50 mm. So, mark the point F1 here. And eccentricity is 2 by 3, 2/3. That means we have to mark the vertex on between R1 and F1 in such a way that ratio VF upon VR it maintain 2/3 and distance R1 F1 is 50 mm. Okay, so mark V1 in such a way that one part is equal to 50 by 2 plus 3 is equal to 5, so 10 mm. So we have to divide this R1 F1 into the 5 equal parts and each part is of 10 mm. Okay, so V1 F1 is equal to 2 part and is equal to 20 mm. So this V1 F1 is 20 and V1 R1 is equal to 3 part and is equal to 30. So 20 by 30 is equal to 2 by 3. So by this way you can find the vertex. Okay, so now plot this vertex V1 on this line. Okay, so eccentricity ratio you can find here. Now from V1, draw one vertical line. Now V1 as a center, radius equal to V1 F1 and draw one arc and this point is Q. Okay. Now join this R1 Q and extend it. Okay. So this angle is a theta. So this theta is less than 45. Okay. Always theta is less than 45 if the eccentricity is less than 1. Now from V1 mark some points 1, 2, 3, 4, 5, 6, 7. Now from point 1, 2, 3, 4, 5, 6, 7, draw vertical lines which are perpendicular to this axis. Okay. Now here the intersection points of these vertical lines are A, B, C, D, E, F, G. Okay. Now important is that in every time center remains constant is F1. Okay. Center remains constant F1. Okay. Now 1A as a radius, 1A as a radius, center F1 and draw arc on this line. Okay. Radius R1. This point is P1. Now center F1, radius 2B. Okay, and draw arc on both sides. This point is P1 dash, P2, P2 dash. Now radius C3, center F1 and draw arc point is P3. Here P3 dash. Force D radius, center F1. You will get point P4, P4 dash. Similarly, mark the point P5, P5 dash, P6, P6 dash, P7 and P7 dash. Now join all these points by a smooth curve. You will get an ellipse. Okay, so this curve is known as the ellipse. Now how to draw the normal and tangent at any point of this ellipse? Now if you want to draw a normal and tangent at this point on the ellipse at point S, then first of all join this point S with focus F1. Okay. Now from F1 draw one line which is perpendicular to this line SF1. Okay, so this angle is 90 degree and the intersection point of this line with directrix is T. Okay, now join this TS. Okay, join TS, so it is known as the tangent. Now from point S, draw one line which is perpendicular to this TT. This is known as the normal. So by this way, you can find the tangent and normal at any point on this ellipse. So this method is known as the directrix focus method. And last one is a rhombus method. So draw rhombus of 100 mm and 70 mm long diagonals and inscribe an ellipse in it. Okay, now let us see a rhombus. Okay, 100 by 70 mm. One diagonal is 100 and another diagonal is 70 mm. Okay, now find the midpoint of this line. Midpoint of this line. Midpoint of this line and midpoint of this side. Okay, these are the A, B, C, and D. Now join this A with this corner. Also join this B with this corner. Join D with opposite corner and join C with opposite corner. Okay. Now this intersection point as a center. This point is 1, 2, 3, and 4. Okay. Now this 1 as a center and radius equal to 1a and draw one arc. Okay. 1 as a center, radius equal to 1a, draw arc. Similarly, 2 as a center and radius equal to 2c and draw another arc. Right. Now here center is equal to 3, radius equal to 3a and draw arc, and also center is equal to 4, radius equal to 4b and draw arc. Okay, so this method is known as the rhombus method, or we can say 4 center method. Okay, so thank you very much, my dear friends. I hope you can understand very well methods of drawing ellipse. Now in our next lecture, we will discuss about the different methods to draw parabola and hyperbola. Okay, so once again, thank you.